Hi everyone, after a bit of a break, I've got a new video. Now this one is all about solving simultaneous equations, just like the last one, except this time one of them is going to be a linear equation, one of them is going to be a quadratic equation. So what we're going to do is we're going to solve y equals x plus 1 and x squared plus y squared equals 13. Just an extra point here. Anything that looks like x squared plus y squared equals something, that's actually an equation of a circle. So what this would look like, the square root of this is the radius, so the square root of 13, which turns out to, I don't know, like 3.5, 3.6. So it means it's going to have a radius of 3.5, 3.6 through the centre there. Not that you need to know that at all for this question, but it's kind of useful, I guess, because if we think about y equals x plus 1, that's going to go through the y-axis at 1. And then it's going to have a gradient of 1. It's going to look like that. So we know there's going to be two solutions to this. So if we don't get two solutions, it probably means that we've made a mistake. Not always, but I expect so in this case. So what we've got is y equals x plus 1 and x squared plus y squared equals 13. Now the way we're going to do this is we're going to substitute something into this more complicated one. Now what we've got here is y equals x plus 1. Now what that means is I can replace anything that says y with x plus 1. That's what equals means. It means the same as. So instead of saying x squared plus y squared equals 13, I can replace y with x plus 1. So I'm going to say instead of y squared, x plus 1 squared. Now by doing that, what we've done is we've made just one variable. We've just got one letter to figure out now, which is x. So then we need to expand these brackets, which hopefully by now you should be pretty good at. So if we expand these using two brackets, so x plus 1, then using the smiley face method, we should get x squared plus 2x plus 1 equals 13. Let me just change to another pen. Now if we simplify that, so I'm going to simplify x squared and x squared to make 2x squared plus 2x. Then I want to get 13 on this side, so I've got 1. I'm going to take away the 13 from this side, so that's going to be minus 12 equals 0. And then we've got a quadratic which equals 0 that we can try and factorise. Now we could try and factorise this by having 2x and x and doing it that way. There is actually a bit of a cheats way here. Because all of these are even numbers and I've got 0 on this side, I can divide absolutely everything by 2. Now, like I say, you don't need to, but it does make it a lot easier. So if I divide everything by 2, that's going to be x squared plus x minus 6 equals 0. And then, without too much bother, we should factorise that to get x plus 3 and then x minus 2. Now just like normal, what we've got is two solutions here. So I've got x equaling minus 3 as the solution for this one, x equals 2 as a solution for this one. Now, just as with normal simultaneous equations, what we then do, once we've got the x, we've got to find out what the value of y is. So here, if I put minus 3 into this, y equals my x number plus 1. So what I'm going to do is I'm going to do minus 3 plus 1 and then 2 plus 1. So if I do that, minus 3 plus 1 is going to be minus 2, so y equals minus 2. If I put 2 into that, I've got y equals 3. Now what we need to make sure we do is we need to link them up. So this minus 3 made this minus 2, so I'm going to say x equals minus 3, and right by it I'm going to put y equals minus 2. And then similarly, I'm going to put x equals 2 and then y equals 3, just so that we know that these link up. Now very occasionally what the questions will ask is they'll say, find the coordinates where this line intersects this circle, especially at A level, because you need to try and apply stuff. Now what we've done, by finding the x and the y, we've found the coordinates. So we can actually say this coordinate is minus 3, minus 2. We say this coordinate is 2, 3. We won't say that every time, but sometimes it will ask you to find the coordinates. So that's the first question. Now the second question is going to be very, very similar. It'll just be one tiny step harder. So if you have a look at the second question from your worksheet, Again, as I always say, if you don't know where the worksheets are, please just email me. Oh yeah, this one is trickier. So we've got 2x plus 3y equals 5. And we've got 2y squared plus xy equals 12. And we've got to solve these simultaneously. Now the thing that makes this one trickier than the last one is that beforehand we had y equals x plus 1, so we already know what we substitute in. However, here we don't have either x equals or y equals. So I'm going to take the linear one, the one without any x squareds or y squareds, and I'm going to simplify that into either x equals something or y equals something. And to make it slightly easier, I'm going to make it x equals. So I've got to try and rearrange this to make x equals. So this plus 3y, I'm going to move on to this side and make it minus 3y. So I've got 2x equals 5 minus 3y. And I'm going to divide through by 2. X equals 5 minus 3y divided by 2. And now I've got an x equals. It's not a nice x equals, but either way we've got it. And then I'm going to rewrite this one, but instead of any x's, I can replace it with 5 minus 3y over 2. So I'm going to write 2y squared plus, instead of y times x or x times y, I'm going to say y times by 5 minus 3y over 2 equals 12. That's the whole substitution thing. So I get rid of the x and I replace it with what x is. And then we're going to try and simplify this. So the first thing I'm going to do is going to multiply everything in this bracket by y. So now, when I say everything in this bracket, it means all the numerators. I don't multiply the denominators. If you times the top and the bottom by the same thing, that's like making a fraction different by times the top and the bottom by 2. It doesn't make it different, it makes it the same thing. So I'm only going to multiply the numerators by y. So that's going to be 5y minus 3y squared over 2 equals 12. Again, it's looking pretty messy. And the thing that's making it look messy at the moment is this divided by 2. So to get rid of divided by 2, I need to times by 2. But I need to times everything by 2. So I'm going to start off with this 2y squared. I'm going to times that by 2. I'm going to get 4y squared. This 5y minus 3y squared all being divided by 2. If I times this thing by 2, I just get rid of the divided by 2. And then I've got to multiply this 12 by 2. So I've got plus 5y minus 3y squared equals 24. And then just like before, I'm going to get everything onto one side and make it quadratic. So if I do that, 4y squared minus 3y squared is going to be y squared plus 5y. And if I move the 24 onto this side, minus 24 equals 0. And then I've got to try and factorise that. So if I factorise that, y plus 8, y minus 3 equals 0. And then I've got my two solutions. I've got y equals minus 8, and I've got y equals 3. And just like we've done in every other simultaneous equation that you've ever done, once you've got the y's, you've got to then find the x's. Now, here, the easiest way to do the x's now, don't go back to one of the original equations, go to the one where you rearranged it to get x equals. So now I know that x is 5, take away 3 lots of my y, divided by 2. So, make a little bit of room here. When y equals minus 8, x equals 5 take away 3 lots of minus 8. Well, 3 lots of minus 8 is going to be minus 24. So it's going to be 5 take away minus 24. That's going to be 29. 29 over 2, and you can either write it as 14.5 or just 29 over 2. I'm going to leave it as the fraction. Then I've got y equals 3. So my x number is going to be 5 take away 3 lots of 3, so 5 take away 9, it's going to be minus 4, divided by 2, it's going to be minus 2. So there we go. Now remember, if you write these ones as coordinates, you need to write them the right way around. So it's going to be 29 over 2 minus 8 and minus 2, 3. Okay, I hope you got on well with that, and good luck with this worksheet.